Hello everyone, my name is Vitor and I am studying Control and Automation Engineering at Federal University of Rio de Janeiro and the software coordinator of UFRJ Nautilus, and I have been here in the team for almost 3 years.
And I'm Lucas, electrical engineering student at Federal University of Rio de Janeiro and the coordinator of electronics team. I've been part of this team for almost 2 years. I'm here with Victor to talk about the propulsion system of Lua, our new CUV.
This new OV was made to improve our team skill and experiment with new technology. So, the two main requirements for a propulsion system was the following. Our new OV must be able to perform movements in all 6 degrees of freedom, unlike our previous vehicle which is not able to roll. The system should be as simple as possible, while featuring secret features like tracer current reading and circuit protections. To comply with these two requirements, our team acquired two more Blue Robotics T200 thrusters, totaling 8 thrusters in our new robot. We chose to maintain 4 of the thrusters in the same spot as before, in the submarine frame. These thrusters are the one responsible for the sway, surge, and the roll motions. As for the other thrusters, we chose to go for a quadcopter-like arrangement, making it in charge of the roll, pitch, and the rev motions.
An entirely new power management system, able to handle 8 electronic speed controllers needed to drive the thruster, featuring current readings by ACS T712IC and sent to microcontroller the information. The protection is made by a switching circuit that contains FET transistors, SCR, and Zener diodes that has to object to shut it down in case of overload or a short circuit, as well as an embedded ATmega 2560 microcontroller responsible for sending speed commands (SPWM) signal from the computer to ASCII, and ASCII is responsible for thrust speed according to the movement requirements. That we're done with the subsystem overview, we can start talking about our competition strategy. Our main goal with this new trusted system for the 2021 RoboSub is reliability. So we want to navigate between tasks and perform the hydrophones and voice tasks without any problem, making UV's localization better, basically performing the same tasks as last year. Build a solid foundation for actuators tasks that demand a fine-tuned propulsion and control system, like object manipulation and torpedo shooting. Also, with a better balance and sharing the loads of pitch and roll actuation between four thrusters, we expect to lower the energy consumption of the AUV to a better battery life and less strain in the electrical and mechanical components of the system.
As for our expectations, we want this new propulsion system to perform as well as the one in BRU, our last vehicle, being able to navigate between tasks, pass through the gates with style points, and finish the run without any issues. Our plan is to use this new propulsion system as the building block to develop object manipulation, torpedo shooting, and marker dropping in the next year. We are already starting experiments in dropper and manipulation tasks with BRU in our simulation environment, but landing a torpedo shot, dropping our mark, or grasping objects was found very difficult to do without controlling the roll movement of the robots.
The development of the system was based on keeping all controlling components inside of only one PCB and not losing our main concept, the modularity. The main challenge was not only changing the previous project but starting a new from nowhere. The last one had the concept to be off the shelf and was made of 6 thrusters. Before mounting anything, a survey was carried out on how the thruster would be positioned in frames. Then, using Auto Designer, the PCB was projected and the main idea was to put all electronic components inside the board, including ASIC and adding a protection system. Beyond connecting the circuit, also parts were patterned for ASIC and for connectors, then the board was printed. Lastly, All external connectors were chosen from buses to connect to the PCB with the thruster. All electronic tests were made in Pro Tools as a simulation. The first part was testing microcontroller HMAG, receiving 5 volts on input and sending PWM signal from its output with a simple code. The result was satisfactory based on expectation, and the frequency could be modified according to the commands. The second was the protection circuit. The simulation was input overcurrent to know if transistor would switch the system. This part works as we projected and is ready for implementation in AUV. Some parts we couldn't test because there aren't ASICs and ACS in any simulation software. The battery is going to lab, but at this moment it's not propitious to do it.
For the software development, we improved our simulation environment in Gazebo, changing our thrusters and buoyancy plugins to utilize the UV simulator framework, allowing us to simulate every aspect of the new propulsion system, from the robot physics to the thruster itself. We started the development of the propulsion system using the same thruster configuration in BRE, seeking for the best spot to place the remaining 2 thrusters. We started thinking about placing them in the sides of the robot, but after analyzing the T200 thruster efficiency curve, we decided to go for a quadcopter-like configuration, allowing us to operate the 4 thrusters that points downwards in a more efficient way. And that's it for the propulsion system of our new AUV. We are very proud of the work that we have been done, and we dedicate this video to each of your team members who made this system possible despite all the difficulties facing during this time. Always keeping a positive attitude. Stay safe and see you next time.